Hello students. Now we will see some more examples based on basic proportionality theorem. Last time you have learnt about basic proportionality theorem and I already told you about its converse. What is basic proportionality theorem? If a line is parallel to any one side of a triangle and intersecting remaining two sides at two different points, then it divides those sides in same ratio. And its converse is what? If in any triangle two sides are divided in equal ratio, then equal ratio due to any line, then that line is parallel to the third side. So see here, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Now today we will have some examples based on this. See, you can see here this figure is given triangle ABC, and here it is the line is passing through point D and E, where D is the point on AB and E is the point on AC. See, what is the question? If a line intersects side AB and AC of a triangle ABC at D and E respectively and is parallel to BC, prove that AD upon DB is equal to AE upon EC. Means here we have to prove that AD upon DB is equal to AE upon EC. Based on what? That line is intersecting at two different points and that is parallel to BC. Means here we are knowing this is parallel to BC. Now see, what we know, D is parallel to BC. So according to basic proportionality theorem, we can say AD upon DB is equal to AE upon EC. Okay. Then if we make invertendo, see here this step is done invertendo. So it is called invertendo steps. Which steps? This step. dB upon AD is equal to EC upon AE. You can see the figure. First, according to theorem, we have written AD upon DB is equal to AE upon EC, and then what they done? It's invertendo, that is dB upon AD is equal to EC upon AE. After that, what they did? They have added 1 to both sides of the equation. So due to this 1, here if we will make the denominator same by cross multiplication, that dB plus AD upon AD EC plus AE upon AE. So dB plus AD it will become AB, and AE plus EC it will become AC. So here we got the step AB upon AD is equal to AC upon AE. What step we have got here? AB upon AD is equal to AC upon CE. So again if we do the invertendo of this, AD upon AB is equal to AE upon AC. Okay. So what was our target? AD upon AB is equal to AE upon AC. That we have to prove. Okay. So what we did here, based on the basic proportionality theorem, at first we apply AD upon DB is equal to AE upon EC, and then we did the invertendo. dB upon AD is equal to CE upon AE, and then we added 1 in both sides, and we have reached on the steps, that is AB upon AD is equal to AC upon AE, and then we again do invertendo. That property is called invertendo. Okay, when we shift denominator to numerator and numerator to denominator. Okay, now Next example we can see. Now based on this basic proportionality theorem, means application of basic proportionality theorem, more 2-3 theorems are there. Out of that, one theorem is based like this example, that is called three parallel lines and their intercept. In another words, here if AB is parallel to EF is parallel to DC. See, if AB is parallel to EF is parallel to DC, then we'll get AE upon ED is equal to BF upon EC, like this. So see here, what is it is given in the example form. ABCD is a trapezium with AB is equal to AB parallel to DC. E and F are points in non-parallel sides AD and BC respectively, such that EF is parallel to AB. EF is parallel to AB, and based on that, what we have to prove? AE upon ED is equal to BF upon FC. So for that, see here, what one construction you have to do. This was the original figure, and this is new figure where we have done the construction. Here A and C joint, AC is passed through the G, so that point is given name G. So due to that, we have got, see here, triangles AEG and ADC. If we'll see the reverse way, CGF and CAB. Now, as you know, here AB is parallel to DC, and similarly EF is parallel to DC. So we can apply here basic proportionality theorem for triangle ABC. So what you can say, AE upon ED is equal to AG upon GC. Same way here also we can apply that theorem, but it will apply like inverse. AG upon GC is equal to BF upon FC. So here what is common? AG upon GC. So directly we can prove this, but let us see how they are proved. See here, let us join AC to intersect EF at G. AB is parallel to DC, EF is parallel to AB, that is given. This is given. Then, due to these two steps, we can say that EF is parallel to DC. See here figure, EF is parallel to DC. And now, if we consider triangle ADC, how I told you, triangle ADC. In that EG is parallel to DC as EF is parallel to DC. So according to theorem 6.1 means basic proportionality theorem, you will get AE upon ED is equal to AG upon GC. See here, AE upon AD is equal to AG upon GC. Okay. Then one more triangle, as I told you, you have to think about CAB or ABC. Again, what they have written in triangle CAB, CG upon AG is equal to CF upon BF. And again we can do invertendo here. Here invertendo. So AG upon GC is equal to BF upon FC. Now you can see these two equations. See, AG upon GC is equal to BF upon FC. Here AG upon GC is equal to AE upon ED. So one side of both of this equation is same. So other side AE upon ED is equal to BF upon FC. So from 1 and 2 we have reached at this step AE upon ED is equal to BF upon FC. Now this was our theorem target. See here, what we have to prove? AE upon ED is equal to BF upon FC. So this is called application of basic proportionality theorem. Okay, or in other words, three parallel and their intercept theorem also application we can say. Okay, now one more example we'll see here. triangle PQR is given. What is the problem here? In figure, PS upon SQ is equal to PT upon TR. PS upon SQ is equal to PT upon TR. And angle PST is equal to angle PRQ. See here, angle PST is equal to angle PRQ. Means this this angle is congruent to this angle. And based on that, what we have to prove? Sorry, here page has gone. See here, what is here written here? Uh, it is given PS upon SQ and PT upon TR, that is given, and ST is parallel to QR also given. Why? Because PS upon SQ is equal to PT upon TR. So due to the basic proportionality theorem, we can say that ST is parallel to QR. And one more information they have given, that is angle PST is equal to angle PQR. Now if you observe this figure, see here, if ST is parallel to QR, then angle S, that is PST, and angle Q, that is PQR, will be also equal or congruent. Why? They are corresponding angles. Why? They are corresponding angles. And similarly, so if S is equal to Q and it given that S is equal to R, then Q is equal to R. Okay. So what we have to prove? Prove that triangle PQR is an isosceles triangle. Triangle PQR is an isosceles triangle. So see the next step. PST is equal to PRQ, that is given, and therefore PRQ is equal to PQR. So these are the two angles, base angles. See here, PST is equal to PQR, it is given, and we know PST is equal to PQR. I have told you already. So from that two steps we have reached that this angle and this angle are congruent. Means for this triangle PQR, base angles are equal. Therefore, if two angles of any triangle are equal, then opposite sides of those angles will be equal. That is called isosceles triangle theorem. So here PQ is the opposite side of PRQ and PR is the opposite side of PQR. So in that way we could prove that two sides of this triangle are congruent. Therefore PQR is an isosceles triangle. Now based on that, exercise is there. Okay. In next lecture we will see some examples based on exercise. So till that you should uh, concentrate on the basic proportionality theorem and its